Good evening. Tonight is Thursday, January the 21st. Today in pre-calculus, we looked at the second part of partial fractions, and I will share my screen and show you the particular type of problem we looked at today. So the only difference we had between yesterday and today, we still have the same type of a problem which we're trying to break down. So if I look at this, in this case, I have an x cubed plus 2x on top. And on the bottom, I have a irreducible quadratic factor, which is x squared plus 1 squared. Now, because this is irreducible, when I set up my partial fractions over here, my first partial fraction will have the x squared plus 1 in the denominator. But because this is a second degree function, the numerator will be a first degree function, so it's going to be ax plus b. And then my second fraction is going to be the x squared plus 1 raised to the second power. So that's going to be x squared plus 1 raised to the second power. And my numerator will be, once again, a first degree term, which is cx plus d. Now, so I do the same thing that I did in the previous situation. I take this whole expression, this entire expression, and multiply it by the denominator here, which is x squared plus 1 quantity squared. So on the left side here, I just have my x cubed plus 2x. And then for my first term here, one of the squares cancel. So I have in parentheses, I have ax plus b times the other x squared plus 1, because I have a square over here. I only have one here. So I'm left with one of the x squared plus 1. And then the second one here plus cx plus d. The denominator is totally canceled because I'm multiplying by x squared plus 1 squared. So that x squared plus 1 squared there and that x squared plus 1 squared there will cancel. So that's what I'm left with. So now if I work this out, I've got my x cubed plus 2x on the left side. I'll just ditto that until I get down a couple of steps. Then I can multiply this here. So I got my ax times x squared, which is ax cubed. And then I got my ax times 1, which I'll put it over here. So that's ax. And I've got my b times x squared, so that's plus b x squared. And I put it in here to keep the powers in order. And then I have b times 1, so that's plus b. And then my last term is plus cx plus d. Now, so what I have to do now, I put all of my terms together, see, so I can bring this down. I can bring my x cubed, and it has a coefficient of 1, and my plus 2x equals, now I only have one x cubed term, and now you notice, and then I have one x squared term, bx squared, but then I have two x terms. I have a plus, so I have plus ax plus cx back here, so I put a plus c times x, and then I have my constant term, which is plus b plus d. Okay, now just as we did yesterday, see, I can compare. So my third degree term here has an a here, and my third degree term over here has a 1. So I know from that that a equals 1. Okay, now there is no x squared term over here, so that tells me that b is 0. So b is 0. And then I look at my x, so I have a plus c on the right equals 2, because 2 is over here on the left. This is my 2 coefficient, and there's my 2 coefficient right there. So that tells me, since a is 1, that tells me that c is equal to 1. And then notice there is no constant term here, so that tells me that b plus d equals 0. And since b is 0, that means that d is also 0. So I'm finished now. So what I have is the partial fraction breakdown of this. So a would be 1, so I would have 1x. So I'd have x here on top, x over x squared plus 1. And then I would have c here as 1. So that would be x over here also. So I'd have x over x squared plus 1. And I would have plus x over x squared plus 1 squared. So that's the last level that we'll look at. What you'll notice here, see, if you have a factor in the denominator here that's raised to a power, you have to have it in each level. So you'd have to have it to the first power, you'd have to have a fraction for that, and you would have to have a fraction for it to the second power. So I will go ahead and stop sharing here. That's pretty much what we did with partial fractions. Tomorrow we'll be looking at linear programming type problems, so I will get back with you tomorrow evening and give you what we did with that. So I will stop recording here.